go. Right, so last time we were looking at something called antiderivatives, but to give it another name, the noun, integrals, and the verb is integrate. So integrals were these things here. But if I want to be even, let me just stick noun here. But if I want to be more precise, more to be clearer, there's an adjective I can put here. Indefinite integrals. So what is an indefinite integral? Well, I'll explain what an indefinite is by showing you what the opposite, a definite, is.
Definite.
You think you know definite?
Yeah.
Yeah, what is it?
You have like numbers.
You have a what?
Like numbers from.
Yeah.
Is from like from 1 to 3 or.
Yes, yes. The difference between what we did in the last class and what we will do in this class is in the last class we did something called indefinite, whereas in this class we're doing something called definite. And the only difference is we have these numbers here in the problem. And these are called limits. Now, you might think, well, that's not much different. It's not much different. It's nearly the same. I'll show you what it means to have these limits. But first, just write this vocabulary down. You okay? Will you tell me at the end of the year what you're always whispering about? Or is it something different each time?
Different.
It is? Okay, fine. Right, continue? Yes? So for example, if I had something like this, 2x, 1 to 3, dx. It's basically the same thing. The first thing we should do is calculate the antiderivative, which is x squared plus c. But now, what's going to happen is we won't care about the c anymore, because what these limits mean is you put in the value of 3, so you make x equal to 3, and then you minus, always minus, the value of the antiderivative when x equals 1. So you can see you don't care about the c anymore because it will always cancel. So you can forget about the c now if you want for these problems. So this will be 9 minus 1, which is 8. Yeah? Let me give you one to try to make sure you have the idea. Can I scroll down? Not yet? Yes? Continue? Okay, try this. 2 over x, let's say 2 to 4. Okay, try this for me. Can I do this one now? So, first thing I'll do is I'll take out the 2. Now I integrate, and that's log x. Oh, sorry. 2, 4. 2, 4. So this is 2, and first you put in 4, minus, then you put in 2. So the 4 goes in first, the 2 goes in second, and you minus. So this will be 2 log 4 over 2, which is 2 log 2. Or if you want, you can write that as log 4, because you can bring the 2 up to the power. But you don't need to do that. 2 log 2. Got that? Yeah? Okay. Can I scroll down? Okay, let me give you another one to try. That's a 9. Yeah. Oh, it's cut off a bit. Okay, try this. Okay. Continue? Yeah. So this one here would be 0 to 9 x power a half dx, which would be x power 3 over 2, 3 over 2, 0 to 9, which is 2 over 3, square root x cubed, 0 to 9. So that's 2 over 3, and then we have here square root 9 cubed minus square root 0 cubed. So let me clean that up. That's 2 over 3 square root 3 squared cubed. That's 2 over 3 square root 3 power 6. That's 2 over 3 3 power 6 power a half. 2 over 3 3 cubed. What happens now? Well, that's like a 1, so it'd be 2 times 3 squared, which is 18. Now what's really nice is, if you have the calculator, I'd recommend it. You can type in
What's the instruction?
wait a sec. It's still loading. Wow, this is taking a long time. Yes, you can do this on the calculator. Oh, okay. So, Let's see if you can see. Whoops, can't see. Hang on. Oh yeah, high def. Get your 3D glasses on. Right. Can we see? So you can actually type in the problem on the calculator, and it gives you the answer. See, 18. Can you see? Now, if you look at the calculator, do you see on my calculator the button? There. See the button? Do you see it? The integration button. Look, there it is right there. Zoomed in. It does take a long time. It does, but it gets the answer.
Does this one have the function?
It does not. I tell you. It does not. The one I recommend does. So you can't just do this, but for the exam you could do this to check your answer. So if I was doing this question in the exam and I got the answer of 18, then I know I've gotten it right. Full marks. I got 18. Yeah, it's useful. Okay. Let's continue. So can we always integrate? And the answer is not always. So let me give an example of when we can't. So, hey, look. This one here we're not allowed to do. Any reasons why, you might think?
There's no value at 0.
There's no value at 0. That's the reason why not. Because, in fact, we'll see in the next lesson exactly the reason why. But when you look here, it's like you're saying x is between -1 and 1. These limits here. And that's okay. But the problem is this here doesn't work between -1 and 1. It breaks when x is 0. So we can't do this, but let me just be a bit more precise here. But we could do something like this. This one is okay, because x here is between 1 and 2, and this has no problems between 1 and 2. So it's fine. So we call this one, I think the vocabulary there is improper. And this one here is proper. I wrote improper, stupid. Improper. Let's have a look at some more examples. So I want you to tell me if it's proper or improper. Can I go down? Okay. Yeah? So proper or improper? Proper. This one here? Proper. Why? You're not allowed to use negative in a root. So this is no good. What about something like something like this one here.
Improper.
Because
Can't be zero.
now this one here, it's kind of proper because remember I said x is between 0 and 1. And I carefully deleted the equal sign last time. So in fact, this one here, just about okay, but it's a little bit unfair. So I'll tell you what, I'll change it to this, make it clearer. Definitely improper now. Yep. This one here, proper. This one here we said is improper. This one here, improper. This one here, proper. Yeah. So you're getting the idea. It depends on what values of x you can and can't use. So for example, just one more. If I said something like, if I wrote this, what value of x can I not use?
2.
X cannot be 2. So if I had here 3 to 4, 3 to 4 is okay because the 2 is not inside of that. But if I wrote minus 3 to 4, then we have a problem. Because now it includes what we can't use, the 2. So this is what I mean by proper and improper. Proper is it does not include any values we're not supposed to use. And improper means the limits include values of x we should not use.
But can we divide them in?
Yeah, then it gets messy and complicated. So we'll look at that in the next lesson. I'll let you try these for a few minutes. You're very sleepy, yeah? Don't worry, I'll give you some maths to do. That will help. Yeah. Oh yeah, actually let me do one more example before I give it to you. No, it's not difficult, but I want to do it here. So, so here's an example. Here I don't tell you the limits. Well, I do. I say the lower limit is 0 and the upper limit is t or k or whatever. And I don't tell you what it is. But I do tell you what the answer is. Find the limit that's missing. Okay, so what do we get when we integrate here? X squared over 2. 0 to t should equal 5. So we need to find the t. So that means t squared over 2 minus 0 over 2 should equal 5. So that means t squared should equal 10. So t is square root of 10. So we have the answer. 0 to root 10 of x dx is equal to 5. The answer was it needed to be root 10 up the top. I've seen this one in the exam twice, but it was actually twice recently. I should actually say about the exam, the way it works is that somebody in Manchester writes your exam. But my experience tells me what happens is they have one person write the exam, and then this one person writes the exam for maybe 2, 3 or 4 years, and then another person writes the exam because this person, maybe they get a new job or they move or whatever. So it is useful to look at the older exams. Of course it's useful to look at the older exams, but it is important to remember that there is a person writing this exam, and the questions that the person writes this year, you know, not that it's the same as what they write last year, but you can see certain features. So for example, I know the person who's writing the exam this year is the same person who wrote it last year, and you know, they like questions like this in the final exam. If you look at the exam maybe 5 years ago, you don't see any questions like this one here. You know, so when we get to do revision at the end of the course for the final exam, it is good if we can look at the past exams, but it's also important to remember that the more recent exams are more important than the older exams because they'll be written by the same person. Okay. So this one here, I put it in because it came up recently in the last 2 years. So you know, it's something that might come up again in the final exams. If not this, some idea like this, where something's missing in the limit. Okay. Or another example might be, you know, maybe something is missing here. Maybe they give you the limit. Maybe they say the limit is root 10, but they don't tell you the constant in the front. So in this example, the t would end up being 1. It's just an idea. Okay. Alright, so what I want you to try now for a couple of minutes is ABC for everything. And you have your calculator as well to check the answer in the exam. So it should be easy peasy.